With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, so the question is variation of displacement x of a particle moving on a straight line with time t is shown in following figure. The figure indicates and there are some options and we have to tell that which option is correct and which is not. Now as you can see that there is a graph between x and t, x is position and t is time. So we know that velocity is basically given by v equals to dx upon dt. Okay, change in distance with respect to time. So this is basically the slope of tangent of xt graph. The velocity is basically equals to the slope of tangent of xt curve. Okay, so now if suppose I am going to take three different points on this graph, and suppose first point is here, second point is somewhere this time, and last point is initial point, final point, and mid point. So if I extend this, so there is an angle, this is the tangent, so there is an angle theta, and we know that slope of tangent is giving us velocity, so that means the velocity is equals to tan theta. Suppose this is theta 1, tan theta 1. Now at this point if I make a tangent, so it make angle theta 2, suppose theta 2, and as you can see that theta 2 is less than theta 1. That means velocity at this time u is greater than, suppose velocity at this point is v1. So I can say when theta 1 is greater than theta 2, that means velocity u is greater than velocity v1. That means velocity is decrease with the time. Okay, now the last point, when you extend this point, it is almost making an angle. Suppose this is angle theta 3, and this angle theta 3 is equals to 0, and tan 0 is equals to 0. That means at this point the velocity, suppose velocity is v2 and velocity is 0, that means this velocity is less than v1. So as you can see that velocity is v2, velocity is decreased with increasement of time. Velocity is decrease. That means there is a retarded position. Motion is retarded when velocity is decreased with the increasing time. That means that position is known as motion is retarded, because our velocity is decreased with increasement of time. Time is increasing and velocity is decreasing. That means this is the retarded motion. Okay, so now just check the options. The first option is the particle starts with a certain speed but the motion is retarded. Yes, this is the correct option, that particle started with a velocity u and when the time is increased, the velocity of particle is decreased with the time. That means motion is retarded, and the final point the velocity is 0. So this is the correct option. Second option is the velocity of particle is constant throughout motion. So this is not the correct option, because as we can calculate that the velocity of particle is decreased with the time. The third is the acceleration of the particle is constant throughout the motion. Now we know that acceleration is basically given by a equals to dv upon dt, and we already know that dv is giving the tangent. So I can write this actually d upon dt tan theta, because for the slope as t, position times slope, the tan theta is giving the velocity. So I can write instead of v as tan theta. So after solving this, a equals to sec square theta, because the differentiation of tan theta is sec square theta d theta upon dt. That means acceleration is depend on the value of theta, and value of theta is variable because value of theta is changing at every point. When value of theta is changed, that means acceleration is also changed. That means acceleration is not constant. So this is the wrong option. And the last option is the particles start with certain speed and moves with increasing speed. So this is also not the correct option, because speed is decreased with the time. So only first option is correct, that the particles start with a certain speed, that is u, but the motion is retarded, and at last point the velocity is 0. Okay, thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.